Hello everybody, this is Mr. Bear bringing you Skill 7B, which is a continuation of what we did the other day with interpreting linear functions. So let's start with a couple of new forms of linear functions. They're not new, but new to our study today. So we're going to talk about the standard form. Standard form looks like ax plus by equals c, and they've identified that you can get the slope by taking the opposite of the a value and dividing it by the b value. By the way, that comes just from solving this top equation for y. So you'd subtract, well, here I'll just model real quick. So if we subtract ax from both sides, you would end up with by equals negative ax plus c, and we'd be dividing both sides by b. So the slope is going to be negative a over b, and the y-intercept will be c over b. You don't have to memorize those. What I would hope that you can do is write those in standard or in slope-intercept form if you needed to find that information out. But that's the shortcut way if you are someone that can memorize those. And then the next one is the point slope formula, which goes y minus y1. Notice the y1 is the y-coordinate of a point on the line, equals m is our slope, times x minus x1, x1 being the x-coordinate of a point that's on our line. Okay, so we have a couple other forms. We have the standard form and the point slope form. So let's look at some examples. Which of the following equations represents the equation of a line with an x-intercept of 6 that passes through the point 3, 2? They tell us the x-intercept is 6. X-intercepts happen when y equals 0. Okay, so what we're going to do is, you'll notice that they give us a point. So we're going to use our point slope form. I'll bring that back up here so we can see what that looks like. So we're going to have y minus our y-coordinate, which is 2, equals m times x minus our x-coordinate. Now x-intercepts happen when y equals 0, so I know that when y is 0, x is 6. So I'm going to replace that on here. So y is 0, x will be 6. And we're going to use that to find our slope. So negative 2 equals, let's see, 6 minus 3 here is 3, so 3m. Divide by 3, and we have to have a slope of negative 2/3. That eliminates the first one, third one, and the fourth one. Okay? When we graph lines, you need to make sure you know how to turn equations into graphs and graphs into equations. In addition to knowing the different forms of a linear equation, it helps to know the slope formula. Okay? Note on here they show some important pieces. Where a graph crosses the y-axis is the y-intercept. Where it crosses the x-axis is the x-intercept. So y-intercept crosses y-axis. X-intercept crosses x-axis. To find the slope between 2 points, you find your 2 points. If you know them on a graph, you could do your rise over your run. Or you could take your y-coordinates, subtract them on top, and then subtract your x-coordinates in the same way on the bottom. Okay, so a lot of information here. So let's look at this one right here. Which of the following is an equation of line L in the xy plane above? So we have an x-intercept at -4 and a y-intercept also at -4. So when we look at that, let's find the slope between those. We go down 4 and right 4. So our slope is -4 over 4, which is -1. Our b, which is our y-intercept, is -4. So in slope-intercept form, I can write this as y equals negative x minus 4. But all of these equations are in standard form. So if we go back up to the standard form, that says ax plus by equals c. So if I have that form of the equation, I need my x and y on the same side. So I'm going to add x to both sides here. And I get x plus y equals negative 4, which is going to be choice C. Okay? I'll let you try this next one, but note that it has a y-intercept at 1. And for a slope, we just find another point that is on the graph. And we do our rise over run. So now just put it into slope-intercept form. Y equals mx plus b. Plug in your m and your b to the equation and select your answer choice. Okay? All right, for these problems, we're going to put on a little bit of what we talked about last class. So we have a graph here that talks about total cost of renting a boat by the hour. Okay? So you can see these dots, and it says the graph above displays the total cost C in dollars. Notice that's your Y variable of renting a boat for H hours. So first we want to interpret the C-intercept. So when I look here, the C-intercept is this point right here, 5. And remember that a y-intercept occurs when, so this is value of C when x equals 0, or I guess I should say h equals 0. H because of the variable names we're using. So is it the initial cost of renting the boat? Is it the total number of boats rented? Is it the total number of hours the boat is rented? Or is it the increase in the cost to rent the boat for each additional hour? Okay, so we'll talk about that in class. So I want you to think about it. Which one is talking about the value of C? So the cost of this, cost of renting a boat when no time has passed. Okay, so think about which of those that would be. And then which equation would we have? Well, we need to know what is the slope. So we can find that by looking at 2 points here. It looks like we rise 1, 2, we rise 3. And notice that when we run, it's 4 spaces, but those 4 spaces make up 1 unit. So our slope is going to be 3 over 1. And then our y-intercept, or I guess our c-intercept, but y-intercept, if we look here, we know that that's 5. So we're just going to put those pieces into our equation to figure it out. I'll let you figure out what that would be. All right, I'm not going to do the 4 corners in class, or not in class, but in this video, because you'll do it in class. So that'll be a good one to talk about. But I do want to talk to you about how to tell if you have a set of data in a table that's linear or not. First thing we want to do is look at the input values, that would be your x's, to see how they change as you move through the chart. Then you want to look at the corresponding output values, that would be y or possibly f of x, and see how they change as you move through the chart. Then what you want to do is check the rates of change between the outputs and their corresponding inputs is the same ratio or not. If so, the data is linear, and then we can write an equation for it. So let's go ahead and try this one out. So let's look at my x's here. I increase by 2, by 2, by 1. Let's see what happens on this side. 3 to 1, I went down 2. 1 to 0, down 1. 0 to negative 2, down 2. What I want to see now is if those ratios come out to be the same. So negative 2 divided by 2 gives me negative 1. I'm going to do a little color coding here. Negative 1 over 2 not going to be, oh, I shouldn't use x there. That is not equal to -1, so this is not linear. And I don't even have to check anything else. It's not linear because we have a set of ratios not the same. All right, we're going to try the next one. On the next one, let's see what happens to the end. So +1, +1, +1 again. And our f of n, so -2 to 1, I'm going up 3, up 3, up 3. All right, and when I look at this, I want to compare the 3 to the 1, the 3 to the 1, and the 3 to the 1. So yes, this is linear. So our m here is going to be that 3 over 1. We don't know the y-intercept here, but I can pick an ordered pair. It doesn't matter which one, I'll just use this one. 2 is like our x, and 1 is like our y. And I can do y minus 1 equals m times x minus 2. Solving that out, we get y equals 3x minus 6 plus 1. So I added that 1 that was from here over there, and that gives me y equals 3x minus 5. Okay. So then here's an SAT problem to determine. We know it's linear because they tell us that this is a linear function. So we want to figure out what equation goes with it. So we're going to check our x's, +2, +2, here +8, +8. M, you take your rise, which is the f of x, and divide it by the runs, which is your x. M is 4. I don't even have to figure out the rest of these because I know that my equation will be C. For question 5, we have to first check and see if this is linear. So we see this is going up by 1, by 1, by 1, and by 1. So it's looking a little trifling. When I look here, notice the denominators are all the same, so we have to really look and see if that numerator, so 11 to 25, we went up 14, so 14 over 4. 25 to 39, that's an increase of 14. 39 to 53 is an increase of 14. And 53 to 67 is also an increase of 14. So my m is 14 over 4, which simplifies to 7 over 2. And because I know this is linear, these don't even make sense. Those are not linear forms. And I can see my slope of 7 over 2 here, so I know D is going to be my answer. Okay. All right. So now you're going to do some practice on your own, and let me know if you have questions.